Let's solve an assignment problem. Actually, an assignment problem is a specific type of transportation problem, but here we have to assign each job to one person or one machine or one department. So to solve the problem, the method we'll follow in here is called Hungarian method. Let's start. We have a shop named Joe Shop. It has to assign 4 jobs to 4 workers. The cost of performing job by each of the worker is given here. It's not same, so it's given here according to the dollar, in terms of dollars. Now we need to find a least cost solution that would the job would be done but with a minimum cost. So to solve that one, I made the tables in here to make it easy. To solve that one, first we have to look at the table, and I'll start drawing in here. It'll be easier for us. So say first one is 50, then 50, 40, 20, 70, 40, 20, 30, 90, 30, 50, 60, 70, 20, 60, 70. So the first thing is we have to see the minimum in each row. So I will write row min in here, minimum in each row. So the minimum in each row is 20 in here, 20 in here, 30 here, and 20 here. Now we will deduct all the items in a row from its minimum. Say the first one would be worker 1 to job 1 is 50, and that should be 50 minus 20. So in the next table I'm doing it 50 minus 20, which is 30, then 50 minus 20, 30, 20, and 0. Same, next one 50, 20, 0, 10, and then 60, 0, 20, 30, then 50, 0, 40, 50. Now we have to choose if if every column has 0, then the next step is not that useful, but you see the first column is has no 0. So now we will choose column min. So column min is, this one is 30 and other columns are 0. So now we will do actually the same process, but now we will consider column. So we will deduct the column min from all the items of each column. So 30 minus 30 is 0, 50 minus 30 is 20, 60 minus 30 is 30, 50 minus 30 is 20. And then we have 30, 20, 0, 0, 20, 0, 20, 40, 0, 10, 30, 50. Column 2, 3, 4 didn't change because whatever you deduct 0 from whatever it is, it will be the same. So we don't have to change it. 40, 30, 20, 0, 0. Okay. Now we have to cut all the 0 with minimum numbers of lines. It could be horizontal, it could be vertical, doesn't matter, but we have to use minimum number of lines. So say if I cut, let me use different color that will be visible. If I cut first 2 zeros with this one, and then we have 2 zeros in here. Do we have one more? In one more in here. So how many lines we have drawn? 1, 2, 3. 3 lines. But the size of our matrix, dimension of our matrix is 4 by 4. So if the number of lines required to cut all the 0 is not same as dimension of the matrix, then this is not the optimal solution. This is not the solution. So we have to do extra step. So one more time. How many lines did you draw in here? We drawn 3 lines. But we have our matrix of our dimension, dimension of our matrix is 4 by 4. So actually it's less than the dimension of matrix. That means we have to do one extra step. What is extra step? Now we have to find the lowest uncut number. Okay, I'm writing it here. Let me change this, not to confuse, sorry. So writing it here, minimum uncut value is, you don't have to write it, but I'm writing it so that we see here what we're doing. Minimum uncut value in here is 20. So now we will deduct 20 from all the uncut numbers, and we will add 20 to the intersection numbers. Here intersection numbers are 30 and 20. So you see here, this is the intersection number, this is the intersection number. And for other cut values, we will not do anything, we will not change them. So once again, we will deduct 20 from all the uncut numbers, and we will not touch the cut numbers, but the intersection numbers, there are 2 intersection numbers. In intersection numbers, we will add 20, not deduct. Okay, let's do it. So 0, 20. Let's do it here. 0, 20. Not going to change. And 20, 0, 0, 10. 20, 0, 0, 10. I will not change them. 20, 0, 0, 10. I'm not going to change these things. I'm writing things that will not be changed. And next to a 0. Okay. Now these two are intersections, so it should be 50 and it should be 40. Sorry, 40. So I added them. Now these are uncut numbers. Uncut numbers are 30 and 20. So that should be 10 and 0. 10 and 0. Then this one is 0, 20, 0, 20, and 10, 30. 10, 30, yes. 10 and 30. Okay. Now we'll do the process again. We will repeat the process as long as we don't get our optimum solution. Let's see. So how many lines do we need now to cut all the zeros? So if I try to do the minimum, 1, 2, I can do 1, 2, it's okay. 3, no, not done, so we need one more, 4, right? If we do it like if I do it in a different way, say, oops, now I cut, sorry, okay. If we do it in a different way, say I cut this one, 1, 2, 3, still we have 1. So whatever the method we are cutting is 4. So when we have 4 lines to cut all the zeros and our dimension of the matrix is 4 by 4, that means this is the optimal solution. Now we need to know how to know which tasks to assign whom, because there are you see there are 2 zeros in some jobs, or some workers have 2 zeros. Which one we will give them? Remember, for this Hungarian solution, these zeros are the optimum. So we have to choose from the zeros. How do we assign them? So to do that one, first we have to see which column or row has only one zero. So first column 2, first row 2 0. And if we check like that, you will see the column 4 has only 1 0. So we assign this one. Okay, so column 4 gone to worker 1. Now worker 1 and column 1 is gone. I'm using let me change the color here. So these two are gone. Now we will not consider about this one. Then we have 3 more left, and then now you see in row 2 has only 1 0. So we will assign task 3 to worker 2. This is also gone for now, and this is also gone for now. Now we have this 2 by 2 matrix, and here you see for row 2 only 1 0. So we assign this one here, and the last one is here left. So this is actually a diagonal one. You see, worker 4 gets job 1, worker 3 gets job 2, worker 2 gets job 1, and worker 1 gets job 4. Now what is the cost? I don't need an extra table in here actually. So the cost should be cost equal, so as a diagonal 70 30 20 20, that should be $70 plus 30 plus 20 plus 20. So total cost is 90, no, 100, 120, 140. Sorry. So the total cost is 140. That's it. We're done.